Okay, so just to remind you of where we were, we have an angle theta in quadrant 2. And so I drew that. We know that the sine of it is 2/3. Okay, the y coordinate over r is 2/3. Then we needed to find x. So we wrote r squared equals x squared plus y squared. And since y was 2, 2 squared is 4. 9 minus 4 is 5. So we got x to be the square root of 5. But we realized then that if I'm in quadrant 2, the only way to get there is with a negative x and a positive y, right? Negative, positive will get me there. All right, so I knew that x had to be negative square root of 5, which meant cosine of theta is negative square root of 5 over 3. Okay, so I have that y is 2, that was given to me. R is 3. I just found that x is negative square root of 5, and that's going to allow me to find the rest. Okay, because we were supposed to find the values of the other 5 trig functions. They told me the sine was 2/3. Now I know cosine. Tangent is y over x, so that's negative 2 over the square root of 5. Okay, and then cosecant, I kind of knew that, I guess, huh? They told me sine was 2/3. I know cosecant is 3/2. Secant, I'm going to flip cosine, so that'll be negative 3 over the square root of 5. And of course, cotangent, then I'll flip tangent, and I'll have negative square root of 5 over 2. This would give you full credit. If you would like a little extra credit, you would take the ones that have a square root in the denominator and rationalize that, making this negative 2 square roots of 5 over 5, making this one negative 3 square roots of 5 over 5. And then that would be it. Okay, but you don't have to do that. All right, the Pythagorean identities come from this idea. We do know that x squared plus y squared equals r squared, correct? That's what we have. Okay. So if we use that and we divide everything, let's say, by r squared, you're allowed to do that, right? I'm allowed to divide an equation by the same number on both sides. That becomes x squared over r squared plus y squared over r squared equals r squared over r squared, which we can call 1. When I have another way to write this is x over r quantity squared, right? When both the numerator and the denominator are squared, I can do that. Y over r squared. And x over r, if we remember, is always cosine. Y over r is sine. So if x squared plus y squared equals r squared, then cosine squared plus sine squared equals 1. And that is our Pythagorean identity. We usually write it, you'll see the Pythagorean identity written this way. Sine squared plus cosine squared, doesn't matter, right? Addition is commutative. Sine squared plus cosine squared equals 1. That's one of the Pythagorean identities. That's the one I remember. I never remember the other two. Because, okay, but what I usually do is divide by like sine squared to get the other ones. I can never quite remember where the 1 goes. So I'll divide everything by sine. Sine over sine is 1. Cosine over sine is cotangent, right? Because now that's a little stretch. We haven't gotten to that identity yet. But since tangent is y over x, that's kind of like sine over cosine, and cosine is x over y. That's or cotangent, I'm sorry, that's cosine over sine. If I have cosine over sine, that's cotangent, and 1 over sine is cosecant. Okay, so that's the other Pythagorean identity. And the third Pythagorean identity, I always derive by, I think about what if I would divide everything by cosine. And then I see sine over cosine, that's tangent. Cosine over cosine is 1. And of course, 1 over cosine is secant. Okay, so Pythagorean identities, here they are, and a nice, this is out of your book. Okay, sine squared plus cosine squared equals 1. That's the most famous. If I divide everything by cosine squared, then I get tangent squared plus 1 is secant squared, and 1 plus cotangent squared is cosecant squared. I have trouble remembering those without deriving them. Maybe you guys can memorize them. And then this is always true as well. Sine over cosine is tangent, and cosine over sine is cotangent. Think about it, guys. Sine is y over r. Cosine is x over r, right? When I divide by a fraction, I multiply by its reciprocal. I'm going to end up with y over x, which is tangent, right? Hopefully that makes sense to you. Okay, but these are some other things that you'll be responsible for memorizing and using, okay? So here they're asking us to use the Pythagorean theorem and the quotient identities we just learned to find sine and tangent, and this is all we know. We know that cosine is this, and we know sine's positive. Okay, so let's think about this, guys. If sine's positive and cosine's negative, I know for a fact I'm in the second quadrant, right? Because sine is only positive in the first and second, where the y coordinate is positive. But if cosine's negative, then I must be over here. So that'll help me realize what tangent is, okay? And sine, okay? Sine's going to be positive. Tangent looks like it's going to be negative, huh? All right, I already know that the tangent is sine over cosine. Well, I don't know what sine is yet. I'm going to use, they told me to use a Pythagorean identity. I know that sine squared plus cosine squared equals 1. So that means that sine squared plus negative square root of 3 over 4 squared equals 1. Now squaring this will give me a positive, right? Square root of 3 squared is 3. 4 squared is 16. Okay, I just have to subtract 3/16 then from 1. All right, don't make this into a decimal. This is 16/16 minus 3/16. So that's 13/16. Okay, just change 1 to 16/16. Little fraction review, huh? And then I'm going to take the square root and get square root of 13 over 4. Okay, I'll take the square root of the whole thing. I can take the square root of 16. It's 4. Okay, so now I know that sine is square root of 13 over 4. Yay. Tangent is sine over cosine. So I have square root of 13 over 4 over negative square root of 3 over 4. Well, when I divide by a fraction, I multiply by the reciprocal. So I'm going to flip, oops, that's not a 13, is it? That's a 3. I'm going to flip that. Boom, boom. I get negative square root of 13 over square root of 3. Okay, now I have square roots everywhere. But if I multiply top and bottom by square root of 3, I get negative square root of 39 over 3. Okay, I told you didn't have to rationalize the denominator. So I would accept negative square root of 13 over square root of 3, but this would be probably the answer you'd see in a multiple choice situation, negative square root of 39 over 3. Okay? All right. Let's try this one then. Find sine and cosine. Given this, I'm in quadrant 3. I always like to draw it. Whoopsies. In quadrant 3. So that the tangent's positive, obviously, in quadrant 3. What do we know about sine and cosine? I have a negative x and a negative y. So I want to remind myself that while I'm doing my math and squaring things, etc., I might end up in a situation, where I think sine and cosine are positive, but they're negative. Okay? So I have tangent, and I want to get to sine and cosine. I can't just say sine is 4 and cosine's 3. That's what a lot of people will do because they know that tangent is sine over cosine. So they'll be like, oh, sine's 4, cosine's 3. Not necessarily here, guys, because it could, you could have a denominator, just like we saw over here. Okay, there could be a denominator, a like denominator. Okay, I do know that 1 plus tangent squared is secant squared, right? That's one of my Pythagorean identities. 1 plus tangent squared is secant squared. So I know that 1 plus 16/9 is secant squared. What's 1? The same as 9/9. Let's add this together. We get 25/9 is secant squared. So that means if I take the square root, I get plus or minus 5/3 is secant. Well, since I'm in the third quadrant, I'm going to take the negative. So secant is negative 5/3, which tells me that cosine is negative 3/5. Okay, cosine is negative 3/5. All right, and now I could use another Pythagorean identity. There's lots of different ways to go here. I'm going to just use another Pythagorean identity. I know that sine squared plus cosine squared, that would be what, 9/25 is 1. So I know that sine squared is 1 minus 9/25. I'm going to call 1 25/25. And that'll give me 16/25. I'll take the square root of that, and I might be tricked into thinking that it's just 4/5. The square root of 16/25 is plus or minus 4/5, and I've already determined that I'm in the third quadrant, so sine and cosine are both negative. Okay, so I get negative 4/5 and negative 3/5. Sine is negative 4/5, cosine is negative 3/5. Therefore, tangent, if I take sine divided by cosine, I'd get positive 4/3. Okay, be careful. It's not necessarily just 4 and 3. All righty. Oh, look at that. We're done. Wow. Okay, so the homework is on page 37, 38, and it's on the Schoology, and it's also on the notes that I gave you, the specific numbers. Please do all your homework, and we'll have a concept check next time I see you in class. All right. Have a great week, guys. Bye.